Welcome back to AI on AI, the show where silicon meets strategy. Today we're zooming into intelligent tutoring systems, or ITS, and why both CTOs and CEOs are suddenly losing sleep over them.
Couldn't agree more. My consulting phone's been buzzing because boards are asking, why are our competitors' onboarding times dropping by double-digit percentages? Spoiler, adaptive tutoring is the culprit.
Right? And under the hood, it's not magic. It's a stack of Bayesian knowledge tracing fused with deep sequence models that update a learner's mastery vector every keystroke.
Hold on, before we geek out, let's remember Sun Tzu's line, every battle is won before it is fought. In corporate learning, that battle is the learner model. Nail it, and everything downstream, recommendations, interventions, feels almost predestined.
But if the model's biased, you just win the wrong war. We recently ran adversarial tests on an industrial ITS and found the mastery predictions skewed 12% lower for novice electricians versus senior techs given identical performance data.
That's a huge governance red flag. In our manufacturing rollout, we baked in algorithmic audits, counterfactual testing every sprint, and brought that disparity under 2%.
Let's unpack one concrete story. Expert 1, you hinted at onboarding improvements?
Sure. A global logistics firm replaced its static LMS with an ITS that uses adaptive paths and a conversational agent for OSHA compliance. Average certification time fell 22%, incident rates dipped 9%, and unexpectedly, employee survey scores on confidence went up.
The tech twist there was combining a transformer-based dialog module with rule-based safety checklists, letting the bot probe misconceptions in natural language, then switch to structured steps.
Building on that, we deployed a similar hybrid for a telecoms fiber splicing academy. The key metric wasn't speed, it was first-time right field repairs. After rolling out step-by-step augmented reality prompts linked to the ITS, first-time right climbed from 68 to 86%.
Interesting, but that brings scalability headaches. Edge devices, network latency, privacy of headset logs. We solved it with on-device inference for the top 10 frequent intents and federated updates nightly.
Which, by the way, trimmed cloud egress traffic nearly 40%. So the ROI isn't just better learning, it's lower infra bills.
Love the cascading wins. Let's get technical. Bayesian knowledge tracing has been around since the 1990s. Why are people still using it instead of pure deep nets?
Well, think of BKT as the 80 in the 80-20 rule. Simple, interpretable, quick. Deep nets give you the extra 20% precision, but cost in opacity. We now ensemble them, BKT for explainability, LSTM or transformer layers for nuance.
Exactly, we call it glass box plus black box. During remediation, the system surfaces BKT's clear probabilities. You're 72% confident on Ohm's law, while the deep net silently routes the next problem.
From a boardroom lens, that transparency calms risk committees. They ask, if the tutor flunks someone, can we defend the algorithm in court? BKT helps us say yes.
Okay, second deep dive. How are large language models, the GPT clan, reshaping ITS?
Biggest shift is synthetic data generation. We fine-tuned an LLM with domain-specific corpora, think turbine maintenance manuals, and used it to generate diverse question-answer pairs. That cut authoring time for new modules by about 70%.
And we layered retrieval augmented generation to ground answers. Without RAG, hallucinations were spiking. With a vetted chunk store, factual accuracy hit 94% in blind tests.
One caution. LLMs still struggle with multi-step math proofs. Our workaround is a symbolic reasoning plugin, essentially a mini-theorem prover, that handles formal steps, then hands the explanation text back to the LLM for friendly narration.
It's the relay race approach. Neural sprinter passes baton to symbolic marathoner.
Beautiful analogy. Now, contrarian moment. What's an overlooked bottleneck?
Everyone fixates on algorithm accuracy, but the hidden sinkhole is content lifecycle. If SMEs can't refresh the knowledge base weekly, the tutor becomes stale and learner trust nosedives. We're piloting Git-style version control for lesson snippets so updates flow like code commits.
That resonates. Our survey showed 57% of dropouts cited outdated examples, not system bugs.
Plus, content drift fuels bias. New safety protocols roll out, old ones linger in prompts, and suddenly your automated feedback is recommending deprecated procedures.
Let's pivot to business economics again. Any examples where ITS directly moved the revenue needle?
A retail chain used adaptive microlearning to train seasonal workers on point-of-sale upselling. Basket size grew 8% quarter over quarter compared to stores without the tutor. The algorithm detected knowledge gaps in promo bundles and pushed 5-minute refreshers pre-shift.
The technical trick was item response theory blended with contextual bandits to pick which microlesson maximizes marginal revenue uplift.
I'd add the automotive after-sales group that launched a VR-enabled ITS for engine diagnostics. Warranty claim rework fell 17%, straight to the bottom line.
Great stuff. Let's touch ethics, data privacy, fairness, transparency.
We embed differential privacy in event logs, Laplace noise at the feature level, so individual traces can't be re-identified, yet aggregate mastery models remain stable.
And we run counterfactual fairness tests, flip demographic attributes, rerun prediction, ensure mastery delta 3%. If not, we refit with adversarial debiasing.
Remember the old Drucker quote, "If you can't measure it, you can't improve it." We publish bias metrics on internal dashboards weekly. That sunlight keeps teams honest.
Any pushback from learners on AI tutors replacing human mentors?
Surprisingly, when we framed the bot as a co-pilot and kept humans for mentorship moments, acceptance shot up. Think of it like autopilot in aviation. Pilots still land the plane.
Plus, collaboration features, shared dashboards where instructors see real-time confusion spikes, turn teachers into strategic coaches rather than graders. There's a cultural angle, too. In regions valuing teacher authority, we let educators record intro videos that the agent plays before sessions. That small human touch raised daily active usage 12%.
Last technical deep dive, dynamic difficulty adjustment. How are you preventing oversimplification that hampers growth?
We borrowed a heuristic from gaming, the flow channel. We calculate challenge skill delta. If success probability exceeds 85%, we spike difficulty by 1 sigma. If it drops below 40%, we insert a scaffold.
We even encode emotional telemetry, camera-based micro-expressions, and feed it into the same controller. A sudden frown yields a hint before frustration snowballs into disengagement.
But we cap intervention frequency. Too many hints, and you get learned helplessness. RAB showed optimal is 1 strategic hint every 90 seconds, not every mistake.
Fascinating. Before we wrap, prediction time. Where will ITS be in 5 years?
Boardrooms will see them as workforce agility engines, not training tools. When market pivots, you update the knowledge base overnight and reskill thousands by Monday.
Technically, expect cross-modal tutors, LLMs plus vision plus IoT streams, offering real-time coaching on factory floors.
And we'll have marketplace ecosystems, third-party lesson packs, analytic plugins, all interoperable via open telemetry standards.
I'll be the skeptic. If we don't solve content ops at scale, we risk another hype winter. The models will be brilliant, the lessons outdated, and learners will shrug.
True, but as Churchill said, success is not final, failure is not fatal. It is the courage to continue that counts. The courage here is iterating quickly on both pedagogy and code.
Couldn't script a better closing line. That's a wrap on today's deep dive into intelligent tutoring systems, where bits meet brains and strategy meets syntax. Thanks to all our experts and to our listeners. Keep learning, keep questioning, and we'll catch you next time on AI on AI. Welcome back for part 2. Listeners asked for a nitty-gritty, how do I build or buy this thing? So we're diving straight into implementation trenches.
I'll kick off with architecture. Every robust ITS still rides on the 4-box model: domain, student, tutor, interface. Think of it like a Formula One car: engine, telemetry unit, pit crew strategy, and cockpit display. If any box underperforms, the lap time, aka learning gain, tanks.
Exactly. And the telemetry here is event streaming, keystrokes, gaze vectors, headset IMU, funneled through Kafka or Pulsar into a feature store. We snapshot every 30 seconds, hash the IDs, then feed both the Bayesian knowledge tracer and a GARU-based deep knowledge tracing model.
Building on that, once those models emit mastery probabilities, the tutor model runs a decision tree we codified in Drools. Business folks love it, because rules can be edited without redeploying the entire stack. Curriculum SMEs push a Git commit. CI/CD propagates new pedagogical tactics overnight.
Hold on, Drools is great for transparency, but we pair it with a reinforcement learning policy for uncharted skills. We sandbox the RL agent and throttle exploration to 5% of sessions until confidence intervals tighten. Governance boards like that guardrail.
From the CFO lens, the burning question is CapEx or OpEx. We've seen mid-sized manufacturers stand up a pilot on a managed cloud at roughly one-third the internal spend because they piggyback on existing data lakes, then shift to an on-prem cluster once usage tops 10,000 daily sessions.
Practical example. How does that pipeline look in week 1 of a rollout?
Step 1. Ingest historical LMS logs into a feature store. Snowflake works fine. Step 2. Run an offline fit of BKT to establish baseline priors. Step 3. Auto-generate 70% of the initial item bank via an LLM with RAG hooked to your domain wiki, then manually vet the rest. Step 4. Push to staging, invite 50 beta learners, capture feedback latency and accuracy. If FB latency exceeds 150 milliseconds, we move certain inference endpoints to edge nodes.
And don't forget cold start mitigation. Use psychometric mapping with 5 survey questions to seed each learner's knowledge vector. That single minute saves you 4 or 5 misrecommended tasks later.
Speaking of recommendations, we found matrix factorization overkill for K-12 math, but golden for corporate compliance, where content is highly modular. It ranks next best lessons with 15% higher click-through than a vanilla Markov bandit.
Let's zoom into evaluation. What KPIs should business leaders track quarterly?
4 North Stars. 1. Normalized learning gain, post minus pre over 100. 2. Retention half-life, basically time until mastery drops below 80%. 3. Feedback precision, percentage of hints that actually resolve the error within 2 attempts. And 4. Operational efficiency, hours of instructor grading displaced.
And map those to dollars indirectly. Shorter certification cycles translate to faster time to revenue. Lower instructor load frees SMEs for higher value tasks. No explicit dollar signs, but procurement teams know the percentages.
Security slice. How are you encrypting this sea of learner data?
AES 256 at rest, TLS 13 in transit, plus we salting learner IDs with a tenant-specific pepper. For analytics, we use homomorphic encryption for aggregate queries, so nobody ever unpacks raw records. Keeps GDPR auditors happy.
We also implement differential privacy with XO equals 1 for mastery metrics before uploading to global dashboards. Adds minimal noise but protects the outliers.
Quick surprise insight. Our blind audit showed that UI clickpath logs predicted attrition better than knowledge scores. Turns out, navigation frustration is a stronger disengagement signal than a wrong answer.
That's why we embedded a Markov decision process to adapt the UI itself. Hide rarely used buttons, surface hint earlier if cursor hovers over the same input box for 12 seconds. Engagement jumped 11%.
Love the micro UX pivot. Now XR implementation. What's the stack for an AR maintenance tutor?
Unity front-end, AR foundation, calling gRPC endpoints for skill sequencing. We cache 3D models locally. The tutor model streams lightweight JSON overlays, arrows, torque specs, so even a spotty 4G plant floor holds up.
And for hand gesture recognition, we fine-tuned MediaPipe on custom gloves. Inference runs on a Snapdragon SoC at 20 FPS, which hits our real-time feedback SLA of sub 200 milliseconds.
Business impact. A heavy equipment OEM recorded a 14% reduction in warranty rework within the first quarter post-deployment. That's board-level relevance.
Contrarian moment. Anybody think LLMs are being overhyped in ITS?
I'll bite LLMs shine in narrative feedback. but for high-stakes algebra proofs, they hallucinate subtle errors. We downgraded them to an assistant role. They draft hints, but a symbolic engine signs off before delivery. Double-blind tests show error rates under 3% now.
Still, that assistant role halves content authoring time. That's not hype, that's leverage. Do what machines do best, let humans do the rest, as Drucker would phrase it if he saw GPT 4.0.
Final implementation tip. How do you keep content current without burning out SMEs?
We run a content pull model. The system flags lessons with declining success rates or external regulation changes, then auto-generates diff suggestions. SMEs just approve or tweak in a GitLab MR workflow, same cadence as code.
Plus, we tag every lesson with a semantic version number and embed that in event logs. So if a bug surfaces, we can trace it back to Geometry Triangles v3.2 instantly.
From a portfolio standpoint, treat content as a digital asset class. Allocate maintenance budget just like you patch software. The 80-20 rule again. 20% of modules drive 80% of queries. Prioritize those.
Quote to close, Einstein said, "Education is not the learning of facts, but the training of the mind to think." With ITS, we're codifying that training loop. Thanks everyone for lifting the hood on both silicon and strategy. Until next time, stay curious and keep iterating. Before we sign off, I want a lightning round. One crisp takeaway each for our listeners.
Well, for me, it's simple. Lock in a rock-solid feature store early. Every adaptive algorithm from BKT to RL feeds off that data nerve center.
I'd add that marrying rule-based transparency with RL agility is the sweet spot. Think of it as explainability with horsepower.
My cue is rigor. A/B test every new model, track normalized learning gains, and you'll steer clear of the inevitable hype cliffs.
Architect privacy by design, encrypt, salt, differentially privatize. Retrofitting security later is like bolting brakes onto a downhill bike, messy and risky.
Tie all of this to board-level KPIs, learning gain, retention half-life, content authoring efficiency, or the budget conversation gets very short very fast.
Perfect. Now let's stitch that together. Today we dissected the four-box ITS architecture, deep dove into Bayesian and GRU knowledge tracing, debated RL guardrails, unpacked XR stacks, and surfaced that unexpected UI friction predictor, all driving double-digit boosts in learning outcomes and operational efficiency. We also tackled compliance, fairness, and the human-AI handshake, echoing Drucker's wisdom, do what machines do best, let humans do the rest. Bottom line, intelligent tutoring isn't a product, it's a living ecosystem that thrives on continuous experiments, ethical stewardship, and cross-functional collaboration. Huge thanks to our expert panel and to you, our audience, for tuning in. This is AI on AI, signing off until the next deep dive. Stay curious and keep iterating.